Good morning, ladies and gentlemen. I have to say I'm very sorry. Actually, right now it's very early morning in Hong Kong. It's let me see, 2:30 around. So actually, I didn't have a good sleep in last night here. Anyway, I just say a few words about today's industrial engineering, particularly my personal view. Okay, and actually I'm just a report a few projects I did in the past few years. Anyway, so I think everybody we are working in industrial engineering, so everybody know what is IE, right? And even today I'm still in my department. Our colleagues still arguing what is real IE. Okay. Anyway, it's some kind of long story because many my colleagues in the same department, they working in the manufacturing engineering. They have very strong background. Okay, in manufacturing, particularly advanced manufacturing technology, like laser processing, whatever. And I'm one of few staff that working in the, I just say traditional IE or even today's IE. Okay, so anyway, for IE, actually it's quite difficult to define. Or even I don't know. Anyway, we have a few keywords. Okay, for example, like optimization, and then so we said optimization what. One is we just say complicated or complex process. Okay, and the system. So that's why even many today's industrial engineering departments changes their name called industrial and systems engineering. Okay, so anyway the definition is quite broad. Okay, anyway industrial engineering actually today we should say have a long history already. As you can see here, the first department in Penn State is like 1909. Okay, it's over 100 years already. And the first PhD is 1930 in industrial engineering. It's in Cornell. Okay, and so today, however, industrial engineering in America most time we're in the College of Engineering or Faculty of Engineering. However, industrial engineering try different compare with other engineering departments. Okay, like mechanical or electronics, or we just call IEEE departments, because for industrial engineering we don't have real product or tangible products or whatever. Normally, okay, we don't consider, let's say, mechanical engineering, you have engine or even automobiles. Okay, for electronics departments, we have like a mobile phone. Okay, design such kind of electronic devices. However, for industrial engineering, we just say we focus on systems. Okay, and traditionally we focus on the manufacturing systems. Okay, and today we have something different. Okay, anyway, so for my project in the past years, and something the first one actually I'm going to say is still in the traditional manufacturing engineering. Anyway, this is something you can see my title. I just say IIE. Okay, so I, and this is something when I prepare this slide is okay. I have been teaching enterprise resource planning for let me see 15 years or whatever. Okay, one thing is I said I try to find some history of ERP or whatever. So I think everybody know what is MRP, right? When we say ERP, enterprise resource planning, right? We have to say the MRP, material requirement planning. And very interesting is the MRP. Okay, you can see it's very early time was developed for very complicated, just I said complex system or process. This is for early time. We want to make something like some products, and this example is for like I say over 30,000 components. Okay, so it's 1940s. Okay, it's really difficult for human to manage. Okay, even for us to remember, let's say 30,000 components. So at that time, really early, people thought, can we use the computer? You know, in 1940s, digital computers, right? That was invented for a few years already. Okay, so that's why the people thought, can we use computer to manage, okay, so many components? And this is good example. Okay, so that's why I said why we need to add an I here, because we at that time actually we had information, we had data already, but even for so many years, even still let's say after 1940s, we had a computer already, but still we cannot use the computer, let's say popularly, or to manage components or products efficiently, or not used popularly. Okay, so that's why today for IIE we can use a computer. Actually everybody. Okay, every day everybody we are using computer. However, in the early time, we had the information I said I here already. Okay, but we just at that time difficult to use, or computer was not used popularly. And actually, this is good. I just say it's a good example for MIP or whatever. And we had big data early. Today it's different. Okay, so that's why one of my project. Let me see. This is for a few years already, and we use we developed something for MIP. Okay. Anyway, for these three subtopics or projects, I'm going to say a few words for each of them, okay? In the next time is 10 minutes or whatever. Okay, so first one, and we understood the MIP problem very early. So we developed, a mathematical model for, for today, many people just call it advanced planning and scheduling, okay? And the problem for early, for even today's MIP or ERP, okay, we still have same problem. And the problem is we call it scheduling for job shop. The problem is, for many products, okay, and each product has so many components. And if this product is not, the demand is not high, or we just very small, and we just call it job shop, okay, which means demand for each product is very small, but the product have many components. And it's quite difficult even for today's computer to solve this problem, because too many components. The schedule problems, particularly the scheduling for job shop and shop floor, okay, which means the manufacturing process. How can we schedule all these components at the lowest level, okay, for shop floor control? And this actually even today's ERP, okay, enterprise resource planning still have this problem. So we developed called APS, Advanced Planning and Scheduling Module, to try to solve this problem, okay. So the ultimate purpose, okay, even today some ERP packages have such kind of capability, okay. They have standalone modules to replace older or traditional MRP, okay. And for this APS, actually, very simply, we just say MIP just for plus scheduling. And anyway, this is actually, it's a long story. I just said that for job shop scheduling, it's quite complicated. For MIP or ERP, and today even we can use it efficiently or effectively for mass production. Okay, which means the demand of products is high. If the demand of some products is very low, and it's job shop, and because computation time or whatever, or some model, even you can see, later I can show you, it's quite complicated. Anyway, and we try to use APS to replace MIP plus scheduling. Okay, so the import for such kind of system, APS system is still we have the import same as MIP, which means MPS. not the production scheduling. Okay, then we need to, the import of products or demand of each product. And then we need to consider components, including raw material parts of each product. Okay, and the output is we need to have schedule. Okay, schedule including one is production, which means the make item or schedule for make item, and also the ordering, which means the raw material. If you, for products, you need to buy some raw material or some components. Okay, for purchasing problem. So the purpose is, we have a schedule for each components and of all products. Okay, and another difference is, traditional MIP, the time bucket, okay, or time unit. Normally we set it in week, and for MPS, because the time is quite short. Okay, we just say, so the time unit for bucket right now, we just consider only days. And even, I have one, real case study, okay? We use, even hours or minutes, okay? I'm going to show you later, okay? Anyway, we developed a mixed integer program model, okay? And I'm not going to say too much details about the model, but I just say something new here. One thing is, in MIP, we have a bill of material. We just call the BOM, okay? And however, for APS, we need, not only the bill of material, we need some information about manufacturing for make items. So here, for some components, okay? If this is, I need a few process, okay? For example, the component C2 is make item, may have, three, manufacturing process. And another component, maybe C2, have also say several manufacturing process. So we need the processing time. Okay. So the BOM 2, we just call it BOM 2, which means bill of manufacturing, and the bill of material, BOM. How BOM 1 just says what kind of material we need for this product. And for BOM 2, we need not only what kind of material or components, also we need some manufacturing information here, particularly what kind of process, and also the machine needed to make these components, and also the time for each process or operation. And the model itself, I'm not going to say, in details or whatever. Of course, some of them is obviously. And however, I need to say a few words about the objective. And the objective here is we have penalty for a product. If this product finished too early, which means we have penalty on earliness. If the product finished too late, of course, this is late delivery, and we also have penalty. And the reason here is we do have the requirement that we try to say finish before the. You can see here it's not the due date. Okay, we just say try to minimize, or we try to finish the products before, it's just the max span. However, max span is not determined. Okay, it will be solved by, get the optimal solution from the model. So it's, Cmax here is not a fixed number. So the question is, how about due date? And the due date actually is here. As I said, if the components of product finish too early or too late, we both have penalty. The reason here is why we have this one. And in reality, some customer order or products definitely cannot be finished before the due date. Okay, in reality. So that's why we should say, we try to finish this products or customer orders before the due date. However, in reality, we cannot. So that's why we have different penalty. Whatever this product is finished before the due date or after due date, certainly after due date, the penalty is higher compared with earliness. Okay, and this is something else is if the product cannot be finished before the due date, what we do is this model is we try to get the product finished, try to as close as to its due date. Okay, which means for this model, the solution is even we cannot finish the product or customer order before due date, still we have a solution. Okay, And this solution, of course, we just says optimal, but the optimal is we have penalty here. Okay. Anyway, for objective, another portion is here is about the penalty on the idle time on machines, because machines are resources, and particularly for, of course, for manufacturing companies, and this is the main resources here. So we have penalty. We try to, of course, to use all machines all time. However, sometimes, okay, I think you understand that due to schedule or whatever, okay, some machines sometimes we cannot use it because we have as constraints, particularly the sequence of operations, or sometimes we just call it route or route of the manufacturing process. And of course, some others, I'm not going to say in detail. Another thing is, and you understand on scheduling, for same machine, we can only make one component, so we cannot have two different operations on the same machine simultaneously. So we definitely have constraints about it. Of course, we have examples, and of course I'm not going to discuss in detail. Just want to say something here. Like this one is quite complicated. And this one only 2 levels, and this one have many levels. Why we have different product structure here, we want to see and the computation time. The relationship between the model solving and the product structure. And what we want to say here, or conclusion we find is, if the product have only few levels, however, each level have many components. For example, like this one, only 2 levels. Actually, level 0 or level 1, and I think level 1 have so many components. Actually, this is more complicated compared with if we have another product have same number of components, however, many levels. And the reason here is obviously, for the same level, we have so many options. Which one we're going to make first? Okay, we have so many options. That's why it takes many computation time to solve the model. Okay, we do have real case, which means I used this model to one company. Okay, and we. Let me see. I can find this connection or not. Yeah, okay. And this is some, Excel file, and all data actually this is real data. Okay, and let me see. Okay, and this is the import. Okay, and actually the product here. Okay, what I can say is it's we call the PCB, printed circuit board. Okay, whatever for today's electronic device like mobile phone or even like a PC, whatever. Okay, we have such kind of components inside it, like a motherboard. Okay, and what you can see, this is real cut model. Okay, from a company in China, and for PCB, printed circuit board, we have 2 sides. Okay. One is top, another one is bottom. So we have components on both sides. So you can see some order you can see here, and the quantity is the same. And however, we said here if front side or not. Okay, if we say 1 or 0, once say 1, which means we have another order, and the quantity should be same, but as components on the other border of this PCB. Okay, so that's why some cut model you can see is 2. Actually, it's only 1 border, but 2 sides. Okay, and after we use our mathematical model. Of course, we have some other information. Okay, like we call it. This is standard information. Sorry for some Chinese, because this is real cut model. Okay, this actually is like standard data, standard process data, which means to assemble one component, how long, okay? And we call it UPH, which means unit per hour. 1 hour, how many units we can do, assembly to process it. And we do have, output for it. Okay, this is what we see, this cut model, you can see for each order you have, this is a real schedule, which means starting time and finish time. And the time unit here, we use a minutes, okay? And for the manufacturing resources, which means machines or a production line, we do here just show you the 4 lines here. So this is the result for F2, the line F2 here, okay? And of course, we have, some other, like this is F3. For F3, we have only products, cut models here. But of course, the time is, we just scheduled it, okay? And the last thing I want to say is, the column Z here. Column Z means, okay, we have different production lines, and the different production line to assemble different components, products, okay? And the total processing time can be different because depends on the unit per hour, because some lines can assemble some products very quickly, some is slower. However, the last line just shows us some product or some cut model cannot be assigned to the faster line because we have so many cut models, okay? Not all, the faster line can be assigned to make products most times quickly, okay? And this is, I want to say here. Anyway, let me finish this and about APS. And even today, I'm still doing, a project about called bioinformatics. This is an example, so we did a few years ago. And I think everybody, we do have a DNA, right? And the DNA is, contains general, genetic information, okay? We just said, even today we find that it's all non-living organisms, okay? Must have a DNA. And even some virus, okay? Anyway, what we do is, for DNA, some of you may notice, we have 2 big classes, okay? One called coding, another one called no coding, okay? Technically, we just coding and no coding. And this is meaningful, okay? So meaningful is for coding we know, okay? So, which means DNA, is very long, okay? And some part, okay, or some section of it is we call coding, some is no coding. So coding normally we just say useful to make a protein, okay? No coding, today even we don't know, okay? We just say no coding, we don't know, what kind of information we will find. We just say we don't know yet. We just say no coding, okay? And very interesting is, we use Fourier transform to find something, for DNA we can see it, or visualization, okay? And what we find is here, if the coding, okay, coding portion, you can see here, just say we call them about 1,000 base pairs, and it's quite long. If no coding, you can see just randomly in the small area. You can see here, actually this is over 3,000 base pairs. However, just in the small area, okay? However, for coding, you can see just less than 1,000 base pairs. However, it's quite long. And this is really interesting, and we find it. And I just show you the real one. This is our human DNA, okay? And you can see here, this is, obviously you can find this is the coding area, okay? However, you can see like here, it's no coding area, okay? And here I just show you, what's details. You can see the first portion of, the coding area is from here, 3,000, let me see here. It's 07 to 4,200 something, which means this is first portion of coding area, or coding DNA. And then second, and whatever, this is not coding area, okay? And you can see it, so we can easily to find this, and what kind of, which portion DNA is used for. So we can, duplicate or we can find other information. And really interesting is, some of you may know it. Okay, how to find this DNA information, or how can we know what is real? And actually, it's only 4 letters. Okay, you understand? And one is A, another one T, and C and G. We just want to find it. And for some, particularly in the early time, we try to find what kind of number, or what kind of letters for all DNA, and it takes really long time. And we find for our method it's useful for the early time because at the beginning, even we don't know exactly, which letter it is, because for each one, and we may have some kind of error, okay? And we find our method can quite stable, even for the early testing or whatever. This is, you can see, for human, DNA, the first portion, no DNA, no coding area. It's something like this, okay? In small, area and just randomly, for over 3,000, code. However, for, you can see for others, very interesting. Anyway, the last one I'm going to say is about, today is, for, I think from last year or in the recent years. It's quite hot, it's about big data, okay? And about 4 or 5 years ago, we started a project about, to get useful information from internet, okay? And so many, online, even shopping or internet website, and very interesting is like Apple's product, right? Particularly like iPhone, and the iPhone, okay, except today's iPhone 6 Plus, right? We have big screen. However, you understand why we have small screen for past few generations of iPhone products, right? Because we have what? Limitation of your hand, okay? And the iPhone was designed to operate the iPhone, use only one hand, okay? So that's why the iPhone screen, in the past, it's always so small. And this is, somebody, the imagination. If we want to use the iPhone, just use one hand, how can we design, next and next until, let's say, iPhone 10, because we have so many apps, okay? So how can we design it? So you can see the iPhone should be, very long, okay? Anyway, I don't know, anybody, you have iPhone 6 or 6 Plus? Right now, okay, so screen right now is bigger now, okay? How can we, to handle so many icons or so many apps? I don't know anybody, he tried it or not. And okay, anyway, it used to be, very long, okay? Today you can see like an iPhone 6, we have a big screen now, 5.5 inch now. And of course, all this is, you can see this is customers' complaint or customers' comments. And for today, many customers or consumers, when you buy some products, particularly electronic products, you have your complaint or comments in the internet, okay? So what we did is, we get such kind of comments from internet, okay? And let me see, I'll give you a real one. Yeah, this is a real one, okay? And somebody can write a very long comments about the products, okay? Some may be short, okay? What we did is we try to get useful information. And this useful information, the first thing is what is useful. And actually we wrote a paper, and this paper published in the computer-aided design. And we just defined what kind of comments is helpful. We just call it helpful. And second question, what is helpful? Okay, we found different attributes, says these comments maybe, and such kind of comments may be useful or not. Another thing is, useful or helpful to what? To whom? Okay, and for us, we just did, I mean, so what we did is just for designer, for product designer, particularly for product designer. And initially, I mean, the purpose of this project, as I said, I mean, just to get useful information to replace, and some of you know it as for QFD, okay, quality function deployment. And the first step for QFD is we need to get what? The customer's information. And traditionally, we just use the customer survey, okay? So we designed the questionnaire first, and then ask the customer to fill the questions. And however, today we just use useful or big data in the internet and online comments. How can we get the useful information to replace the customer survey? And of course, there are so many, questions. You call the I survey or whatever. The first question is like the traditional questionnaire was designed in a fixed format. Okay, you can even sometimes you can just pick up and say yes or no. However, the comments in the internet, free format, whatever you can say. Okay, you can you can say bad, you can say good words. Okay. And it doesn't matter to us because we just say we just get the useful information for product designer. So here is what we want is we want the bad comments on our products, which means your comments may provide some useful information. For example, we said earlier, your screen too small, or maybe your product too heavy. Okay, and even, today we still have comments, for bad comments on battery. The battery is, life too short, also the duration, okay? Like Apple's products, like iPhone, normally you cannot operate it within, let's say a few hours is fine. Longer time, let's say 6 hours or 8 hours, normally cannot, okay? And we just want to find such kind of useful information for our products. Okay, anyway, I think, I should finish. And this is, I just say, for today's, so all these products we finished already, okay? And for next, what we're going to do is, and my next project is we try to have, QFD in internet, which means get all information, for example. And we want to do next is how to compare products for similar products, okay? Like iPhone with, Samsung products, okay? Get all information from internet and then get such kind of conclusion, which feature or which particular engineering feature is better. And for bioinformatics, the next project I'm going to do is about, actually I said here already, and we try to use the continuous time micro model in, bioinformatics, okay? I think I have to finish here. Anyway, thank you very much.